Well, now we start doing an exercise series on surds. Okay. Before we do that, I'm gonna move it a little bit here. It is important to note that square root of the nth root, okay, of a times b, this is equal to the nth root of a multiplied by the nth root of b. So those formulas are useful from left to right as well as from right to left. Like in this question, right here, we have like square root of 7 multiplied by square root of 3. This is like square root of 7 multiplied by 3. Okay, this is equal to square root of 21. Okay, let's move a little bit up there. And then b says the square root of 7 multiplied by square root of 7 plus square root of 11 raised to the power of 2. Okay, note that square root of 7 multiplied by square root of 7, this can cancel. This we cancel because it makes 7 times 7, which is 49, and square root of 49 is 7. This cancels the radical signs. Okay, this makes this is equal to 7 plus, and then the square root of the power of 2 will also cancel the radical sign there, and that makes 7 plus 11, which is equal to 18. C, the question says that 2 roots of 3, okay, raised to the power of 2. This is like 2 to the power of 2, okay, and then root 3 all to the power of 2 also. Now the power of 2 here, we cancel this root, and then 2 squared is 4, multiplied by 3, this is equal to 12. Okay, we can do d over here. Then we have like 3 root 6 minus root 6 plus 7 root 6. Now, the fact that each term, here we have to separate the term because we don't have products. I have minus plus here, separate the expression into terms. This is a term, this is a term, this is another term. Because in this case here, each term has square root of 6. We can just do 3. Understand that over here there is an invisible one, okay? So basically, we do 3 minus 1 plus 7, which is 9, okay? And then that makes 9 roots of 7, 9 root of 6, I mean. E. Over there, if you look at E there, each expression also has fourth root of 3, So there, I can just put a 1 here in front of the fourth root of 3. So you just do 1 plus 7 minus 5. Okay, 1 plus 7 is 8, minus 5 is 3. So the answer here is just 3 roots, fourth root of 3. Okay, and then F, root of 3 plus a root of 27. This is like a root of 3 plus root of 27 is equal to 3 roots of 3. Okay, you can do it. Let me prove it over here. I'll prove it here. Let me write it over. F square root of 3 plus square root of 27. This is like square root of 3. 27 is, if you do 27 in terms of its prime factor, you get 3 to the power of 3. Okay, this is 3 to the power of 3. Now, to solve this, I prefer to break this, okay, into instead of me writing here square root of 3 to the power of 3 there, I'll write it like square root of 3 squared multiplied by 3. Okay, so this can be broken into square root of 3 plus square root of 3 squared multiplied by square root of 3. Okay, and then the square root and the power of 2 will cancel, and then this is just like square root of 3 plus 3 root 3. Now the fact that they both have square root of 3, this will be like, understand that there's an invisible one over there, so we will do here 4 square root of 3. And then we can also do question G. 2 root of 18 minus root 32. Again, over here, we can write each, we're going to write all this in terms of the prime factors. So this will be 2 root 18 in terms of prime factors, like 2 times 3 squared minus square root of 32 in terms of its prime factor. This is just 2 to the power 5. Now, over here, we write 2. We can split this, okay, into square root of 2 times square root of 3 squared minus square root of root 2 to the power 5. We can write it as like square root of 2 to the 4 times 2 to the 1, okay? And then we can break this again. Okay, over here it's gonna be like 2 times root 2, and then there the power of 2 and the square root cancels. We left with times 3 minus, there it's gonna be like square root of 2 squared, 2 to the power 4, I mean, times square root of 2, okay? And then we can simplify. 2 times 3 makes 6, so that makes 6 roots 2 minus 2 to the power of 4 roots, square roots, we do, as we were saying, that the nth roots of a to the m equal to a to the m over n. So we do 2 to the power 4 over 2. When we don't see any indices here, understand it's just 2. Okay, it's like 4 divided by 2, which is 2. So that makes 2 multiplied by 2, 2 multiplied by square root of 2. Now, the fact that the whole n with square root of 2, we can just combine 6 minus 2, which is 4, and then that's answer 4 square root of 2. Okay? Now we can do h. H was root 32 over root 2. Now we say that root 32 is like square root of 2 to the power 5 over root 2. And then this is like root of 2 to the 4 times 2 over root 2. This can be broken down into root to the 2 to the 4 multiplied by root to the 2, root 2 over square root of 2. Then we can simplify this one and that one, and then the answer is just 2 to the 4 over 2, which is equal to 2 squared. And that's equal to 4, okay? That's equal to 4. H, and then we can do I. What is actually question I there? That says what? The cube root of 51 over, what was that again? Okay, question Y, question I is cube root of 51 over cube root of 3 over cube root of 3. Now 51, if I need to write 51 in terms of its prime factor, 51 divided by 3 is 17. So it's gonna be cube root of 3 times 17, okay? All over cube root of 3. This can be written as cube root of 3 multiplied by cube root of 17 all over cube root of 3. Then we can simplify. Cube root of 17. Multiply by, let me just move it like this. Okay, no. We can say multiply by 1, but I don't need to, as long as we simplify that, is the final answer. Now the next question will be J. Square root of 32 over 2. So it's similar to I here, say J. square root of 32 over 2. This will be 2 root. Okay, let's go step by step. This is 2 to the power 5 over 2. And then square root of 5 is like square root of 2 times square root of 2 times square root of times 2. Okay, because the power of 1 is there over 2. Now, why am I doing like this? Because 2 plus 2 is 4, plus 1 is 5. Okay, we can split it this way. And then this is like square root of 2 to the power of 2 multiplied by square root of 2 to the power of 2 multiplied by square root of 2 to the power of 1, or just write square root of 2 over 2. Then square root of 2 to the power of 2 is just 2 times square root of 2 all over 2. Then we can simplify these 2 and that, and then the answer is just 2 roots 2. J. And then next question is K. Question K is root 54 over 9. Root 54 over 9. Okay, that will be equal to 54 in terms of its prime factors. It's going to be root of 2 multiplied by 3 to the power of 3. Okay, so I prefer to write in that's 54 in terms of prime factor. Okay, over 9. Over 9. Now we can write root 2 multiplied by root to the power of 3 squared multiplied by 3. That makes 3 to the power of 1 over 9. And then we can see simplify further. This is like root 2 multiplied by root 3 squared multiplied by root 3 over 9. Okay. And then over here, the roots and the power of 2 cancels out. And then we have left with, it's going to be like 3 multiplied by square root of 2 times square root of 3. Square root of 2 times square root of 3 over 9. Now here we can simplify 3 and 9. Okay, it's going to be 3 there. And then root 2 times root 3 equal to root 6. So that makes root 6 all over 3. Okay. K, L. Says root 8 plus root 2 over root 2. So root 8 in terms of its prime factor is root 2 to the power of 3 plus root 2 all over root 2. Now root 2 to the power of 2 can be written as 2 squared times 2, okay, plus root 2 over root 2. Now we can split that into root 2 to the power of 2 multiplied by root 2 plus root 2 over root 2, okay? And then that makes what? 4. That makes over here, the roots and the power of 2 cancels out. So the answer is like 2 roots 2 plus root 2 all over root 2. Now we can simplify, we can take root 2 for common factor because it's both sides there. We can take it as a common factor, and then it's going to be like root 2 open brackets, close brackets. There it's like 2 plus 1, okay, because there is an invisible 1 over there by root 2. Now all over root 2, and then the 2 here can be simplified, and the answer is just equal to 3. Okay. Now we still have more questions to do. I'm gonna post the rest of question 1. Okay, let me just erase all these. Erase all these. Poster. Right, now we have M there. root 50 minus root 2 over root 8. So over here we have like right here m root 50 minus root 2 over root 8. So we can write root 50 in terms of its prime factor, it's going to be like 2 times 5 squared minus root 2 over 8 in terms of its prime factor is 2 to the power of 3. Okay, so now we can split it into roots. Like it's gonna be like root 2 times 5 root of 5 squared minus root 2, and then root of 2 to the power of 3 can be written as like root of 2 squared times 2. Okay, so this will be note that over here we have like a common factors, so we can write root 2 for common factor, and then this will be at the denominator there we can split it also into root 2 squared times root 2, and then there it's going to be root of 5 squared is just 5 because the root here and the power of 2 will 4, which will be simplified, so we have left with 5, and then minus what? Okay, we're not going to say minus 0 because it's assumed that there is a 1 there, so it's actually minus 1. Now this will make like root of 2 multiplied by 4 all over 2 times root 2. Now we can then simplify this root and this root, and then 2 and 4 there we have left with 2, so the answer is just 2. Okay, and then we can also do n. N, well, like the cube root of 16 minus the cube root of 54 all over the cube root of 3. Now we first going to write all in terms of the prime factor. So root 16, cube root of 16, 16 in terms of the prime factor is 2 to the power of 4 minus, excuse me, 54 in terms of its prime factor, this is equal to 2 times 3 to the power of 3 all over 2 is already a prime number, so I just want to say cube root of 2 there. Now, because the indices here is 3, okay, same there, same there. In this case, I will not split it like 2 squared times what, but I will split it like 2 to the power of 3 times 2, okay? So the numerator here will be cube root of 2 to the power of 3 times 2. I split it like that because the indices is 3, okay? So that's to the power of 1 minus sum also here, so this will be like root 2 times the cube root of 2 and then cube root of 3, and then all over cube root of 2. Then we can split this as a cube root of 2 cube multiplied by cube root of 2 minus cube root of 2 multiplied by cube root of 3 all over cube root of 2. Then note that we have like a cube root of 2 cubed, cube roots of nope, we have like this should be the common factor, okay? So we will write here cube roots of 2 for the common factor, and then over here cube roots and the power of 3 will be simplified, and cube roots and the power of 3 will also be simplified. So we will write there 2 minus 3 all over cube roots of 3 there, and then we can simplify this and that, and the answer is just -1, okay? That was question N, and we can also do question O. That makes square root is square root of 48 minus square root of 32 over square root of 12 minus square root of 8, square root of 12 minus square root of 8. And then 48 in terms of its prime factor, this will be it's 3 times 2 to the power 4, okay? Minus 32 is 2 to the power 5 over square root of 12 is 3 times 2 squared minus, that makes 2 to the power 3. And then what's this? We can split this one into root 3 times 2 to the 4 minus roots, that makes 2 to the 4 times 2 times 2. I use 4 because I know the indices here just 2, okay? So we can leave the exponent with an even. We can leave an even exponent here. Instead of writing 2 to the power 5, I write 2 to the power 4, okay? And then all over what's root 3 multiplied by root 2 to the 2 minus root 2 squared multiplied by 2, okay? So this will be root 3, root of 2 to the power 4 will be written as 2 to the power of 2 because we simplify the exponents. So it's like 4 over 2 there, okay? Minus, that also makes 2 to the power of 4 over 2 times root 2 all over square root of 3 multiplied by 2. Over here, we simplify the exponents. And then also minus square root of, that makes what? 2 multiplied by square root of 2. Now, what is this? 2 to the power of 4 is 2 to the power of 4 over 2 will make 2 to the power of 2, which is 4. I can write here 4 roots 3 minus, that also makes 4 roots 2 over 2 roots 3 minus 2 roots 2. So we can take over here at the numerator, I will take 4 for the common factor because that's a common factor. So I'll take 4 for the common factor here. We have 4 and 4 there. I'll take 4 for the common factor, and then that will be root 3 minus root 2 all over. At the denominator, I'll take also 2 for the common factor. That will be root 3 minus root 3 minus root 2. And then over here, we can simplify that, and then the answer is just 2. Okay? We continue. We're gonna do a question P. Well, now we can do question P. Let's try here question P. It is given that 5 minus square root of 3 multiplied by 5 plus square root of 3. So to solve this, understand that this is a product that leads to the difference of two squares. Remember that we did learn that A minus B multiplied by A plus B is equal to A squared minus B squared, okay? So we can apply this property to solve this question here. Note that this is like our A and that B, and this is like A and that B. And then this is 5, that's root 3, 5 root 3, and that makes 5 and root 3 there. Now let's go solve this. This will be then 5 squared. So we're going to do 5 to the power of 2, okay, minus square root of 3 to the power of 2. So now on right here, 5 raised to the power of 2. And then square root of 3 also raised to the power of 2. Now this makes 25 minus square root of 3 is 3, and then that makes 22. Okay. We can continue. We can do question R, which is given by 5 root 2 minus square root of 3 raised to the power of 2. Now this is also this property is called the perfect squared. We do know that a minus b to the power of 2 is equal to a squared minus b squared. No, a squared minus 2ab plus b squared. Okay, so we know that this is our a and that b. So this is 5 root 2, that's root 3. So we're going to substitute here. It's going to be equal to, let me put this for a squared minus 2ab, okay, plus b squared. Then if I sub in the values, like a squared is like 5 root 2 minus 2a, which is 5 root 2, 5 root 2, and then b is root 3 plus b squared root 3 squared. Now we can simplify. Note that the power of 2 here is for both 5 and root 2. So this is like saying 5, and then I can just put another bracket there. So it's going to be like 5 squared and then root 2 squared, okay, minus here we can times 2 and 5, that makes 10, and then we have like root 2 times root 3, okay, plus there we can simplify the power of 2 with the square roots, so it's just equal to 3. Then 5 squared is 25, and then root 3 and the power of 2 we cancel out, and then we have 25 times 2 minus 10 roots 2 times root 3 can be combined and makes root 6, okay, because the indices are is the same, they're both square roots, okay. So you know, square root of a, let me write it here, square root of a times square root of b equals just square root of a times b. You can combine this one to product, and then plus 3 there, that makes 50, 25 times 2 minus 10 root 6 plus 3, and then this is equal to 50. 3 minus 10 root 6. Okay, that was question R. I think I didn't do question Q. Question Q is quite similar to question R. It's like 5 minus root 3 to the power of 2. We apply the same formula here, and then this will be to the power of 2, a squared minus 2ab plus b squared, okay? Now, we can sub in, we know that this is a and that b, so we can substitute. That makes 5 squared minus 2ab plus b squared, and then 5 squared is 25 minus that makes 2 times 5 is 10 root 3, and then the power of 2 there, and then the square root cancels, so that makes plus 3. Okay, and then this will be equal to 28 minus 10 root 3. Right now we're gonna do question S. Sorry. Let's just move a little bit up there. S is given by 2 root 5, open brackets, root 5 minus 3 root 20. Okay, so now first of all, I prefer to simplify what is in the brackets here. Root 20. Root 20 can be written as this can be written as 2 root 5, and I can prove it to you. Like 20, I'll first do it in terms of a prime factor. By 2, it's 10. By 2, it's 5. And then 5 by 5 is 1. So this is like 2 squared times 5. Now, if I square root it, okay, I square root it like this, and then I'll get 2 root 5. So that's why it is the way it is. Or I can also use a calculator. If I do like square root of 20, like that, I hit equal, and then we got 2 root 5. So this is like 2 root 5. Then this expression can be written as 2 root 5, okay, open brackets, root 5 minus 3 times 2 makes 6, okay, negative 3 times 2 makes negative 6, root 5. It can be rewritten like that. Now we can times, okay, times we do we distribute it. It's going to be like that, and then this will be 2 root 5 times 2 root 5, so 2 root 5 multiplied by root 5, I mean, and then negative 2 times 6 makes 12. So let's just say 2 times 6 root 5 times 2 root 5 multiplied by 6 root 5. Now, note that the root 5 here and the root 5 there will cancel, will just make 5. So it makes, over here, it makes like 2 times 5, which is, this makes 2 times 5 minus 2 times 6 times 5, okay? And then that makes 10 minus 12 times 2 times 6 is 12, 12 times 5 is 60, and then we can do that makes is equal to negative 50. Okay, and then we can do question T. Well, question T is given by root 5 plus 2 root 3 to the power of 2 minus 5 minus, not 5, but root 5 minus 2 root 3 to the power of 2. Now, over here, we can apply the difference of 2 squares, okay? You know, we said that when you have like, this is like A plus B, okay? And then A minus B. The property says that when we have like A squared minus B squared, this is equal to A minus B times A plus B, okay? So all this, excuse me, it's not really that, what I wrote here on top, but rather all this makes, this is like A, the whole thing is like A, so A squared. Okay, all this, the one I highlighted is like A, let me write it underneath here, it's like A raised to the power of 2. And then this other part here is like B, okay? So A squared minus B squared. So this will be then equal to square root of 5 plus 2 root 3, okay? This is like A. A minus B, sorry, I prefer to write it. You'll think it's like A here minus B. B is root 5. Okay, let me write this way to avoid confusion. I need to involve the square bracket. So we have here square root of 5A plus 2 root 3. This is like A minus B, then I use brackets. So root 5 minus 2 root 3, that's A minus B, the whole thing here. Okay, or I can just put bracket there also. Multiply by A plus B, so it's like root 5 plus 2 root 3 plus root 5 minus 2 root 3. So this is B, this is B, and that is A, and that is also A. So you see, A minus B, okay, and then the A plus B. Okay, so if I drop the round bracket within the square bracket here, this will be root 5 plus 2 root 3, okay, minus root 5 plus 2 root 3, okay, because the minus outside, okay, the round bracket here change the sign of everything within the bracket. And then over there, it's going to be like root 5 plus 2 root 3 plus root 5 minus 2 root 3, okay? And then note that root 5 minus root 5 falls here, and there also, there it falls. Now, 2 root 5 plus 2 root 5, okay? We can just do 2 plus 2, that makes 4. 2 root 3 plus 2 root 3 makes 4 root 3, multiplied by root 5 plus root 5 makes 2 root 5. And then this is just 4 times 2, which is 8. And then root 3 times root 5 makes root 15. Okay. We can continue. I do question. The next question is question U. Not U, but the letter U here. Question U says 2 root 8m, open brackets, open brackets, square root of 2m, okay, minus 3 root 18m, okay. So before I solve this, I prefer to simplify this root here. You know, I know that 8 is a cube number, so this will be equivalent to say 2 root 2m. Why am I saying that? Because if I do in the calculator, I do like square root of 8. See? Makes 2 root 2. So I can over here I write just 2 root 2m because the 2 here is still in the root, and then m also. And then this makes like 4, because this 2 times that makes 4. 4 roots of 2m, okay, open brackets, roots 2m minus sum also of the 18 here. 18 is the same as to say 3 roots 2, okay. And then with the m, I'll say there, because you can check in the calculator. Even if the question says solve without the calculator, this can be checked the calculator, nobody will know. If you do like a square root of 18 there, and then you press equal, that makes 3 root 2. 3 root 2, and then 3 times 3 there makes 9, so negative 9. That makes 9 root 2m. Okay, you can reduce it that way. Now, that's, you express it in terms of root 2m. Then we can do all these times that, and all these times that, and then that makes 4 times root, so this makes like 4 root 2m multiplied by root 2m minus 36 root 2m multiplied by root 2m. Now, root 2m times root 2m will cancel, just makes 4 multiplied by 2m minus 36 root 2m times root 2m will make again 2m. And then 4 times 2, that makes 8m minus 36, not 36, by 72m. And then 8 minus 72m makes 64, negative 64m. Okay. We can continue. We can do question V. the last question here. Question V is given by 10 square root of 2x to the 20, okay, plus 7 square root of 8x to the 20 also, all over square root of 18x to the 20. Now, note that we can simplify. Yes, we can simplify x to the 20 because this makes like 10 square root of 2 multiplied by square root of 20, x to the 20, I mean to say, plus 7 square root of 8 multiplied by x, square root of x to the 20, all over square root of 18 multiplied by square root of x to the 20. So that this makes what? 10 root 2 x to the 10, okay, plus 7 root square root of 8 is something as to say 2 roots 2, okay, multiplied by x to the 20 to the 10, all over square root of 18 is 3 root 2 x to the 10, okay. Then we can look at the numerator here. We have like root 2 there and root 2, and then x to the 10, x to the 10. It can be taken as a common factor. So we can write over here root 2 x to the 10 for the common factor, and then within the brackets there should be we left with 10 plus over here 7 times 2 makes 14, okay. So I see here 14 all over 3 root 2 x to the 10. Now we can simplify root 2 x to the 10 x to the 10, and then that makes what? 10 plus 14 makes 24 over 3, and then this is equal to 8. And then we got V. Thank you.